All right, guys, welcome to the first video, section 9.3, day 1, solving quadratics by graphing or factoring. And we're going to start by filling out this little graphic organizer. So when I have you guys solve a quadratic, when I say solutions, I mean the solutions of a quadratic equation are values of x when you set the equation equal to 0. Now, some other words you might hear instead of solution could be zeros or x-intercepts or solutions. Okay, those all mean the same thing. On to the next box. The solutions of a quadratic equation, like we just said, are also known as the zeros or the x-intercepts. Solutions can be found by looking at a graph and looking at the x-intercepts. All right, let's put this together in a picture. So if you guys could, go ahead and draw an xy axis and draw a parabola, just some kind of U facing up. If I asked you to circle where the solutions are, where would you guys circle? So hopefully if you were paying attention, you would circle the x-intercepts. So that would be right here and right here. These are what the solutions look like on a graph. Okay, and then let's skip this. Nothing right there. All right, go ahead and flip it over and let's practice now. We're going to start by, can you find the solutions based on a graph? And don't make these hard. Literally, you find your U. Where does it cross the x-axis? Those x-intercepts are the solutions. That's it. So this one has solution at -1 and +3. That's all you have to do. Those are the solutions. Number 2, where does the graph cross the x-axis? The graph crosses the x-axis right here at 1. So the solution is 1. Now, number 3, you look and you say, okay, well, this U actually does not cross the x-axis. And if it does not cross, then there are no solutions. None. And lastly, number 4, where does the graph cross the x-axis? It's here, and that is at 2 and 4. So it's super easy to find solutions by looking at a graph. Okay, now what if you don't have a graph? And if you don't have a graph, the way that you are going to solve is by factoring from Chapter 8. Okay, so we can find the x-intercepts or solutions of a parabola by factoring. This means we can use factoring to find the zeros. Okay, so here's how we do it. Make sure your equation is equal to 0. It must be equal to 0. If it's not, you may need to rewrite it by rearranging some things. And then you factor completely, and then set each factor equal to 0 and solve. And we're going to practice a bunch of these on the back. All right, let's try. So, no graph, so we have to do these by hand. It says solve by factoring. First thing you guys want to check is it equal to 0? If it is, we are good to go. So now we factor. And the first thing you want to do is see if you can pull out a GCF. Is there any common term that we can pull out of all three? And I think just a W. So go ahead and divide everything by W, 1W. You get W squared minus 8W plus 16 equals 0. Okay, then the trinomial in parentheses, we can factor more. Do you guys remember how to factor a trinomial? We need a multiply-add table. So we need to find two numbers that add to the middle, -8, multiply to the product of the first and last, 16. So go ahead and find two numbers that multiply to 16 but add to -8. And hopefully you guys come up with -4 and -4. Now I'm going to show you guys the shortcut because I know you guys can plug them into the middle, factor by grouping, but now that we're good at that, it's time to learn the shortcut. If you get -4 and -4, then when you factor, it's W minus 4, W minus 4. Okay, no need to plug them in and factor by grouping. These numbers are your factors. -4, -4 is W minus 4, W minus 4. All right, let's drop down the GCF. And let's drop down the equal 0, and now we solve. Okay, so how do we solve? We actually have done this before. When you solve a bunch of factors equal to 0, you set each one equal to 0 and solve. So let's do this one first. W equals 0. Well, there's one answer. Let's do this one next. W minus 4 equals 0. Now this one you actually have to solve by adding 4 to both sides. So this one gives you W equals 4. And now let's do this one. Well, this one's actually the same as this one, so we don't have to do it again. So the solutions are 0, 4, and 4 again. Right? Because you had a repeat. So 0, 4, and 4. Those are your solutions. Okay, we're just going to keep practicing these. Same thing over and over. So number 2, here's a problem. It's not equal to 0. So we need to draw our wall and rewrite it so that this guy is over on this side with the others. So to move a minus 24x, we're going to add the 24x to the other side. So let's rewrite our problem. Now we have 3x cubed plus 18x squared plus 24x equals 0. Now we can start factoring. And as always, the first step is, can we pull out a GCF? What do all three terms have in common? What can we take out of all three? And I hope you guys see a 3x. So let's divide that out. We're left with 1x squared plus 6x plus 8 equals 0. And just like before, we have a trinomial here in parentheses that we want to try to factor more by using a multiply-add table. We need two numbers that add to the middle, 6, multiply to the product of the first and last, 8. What are two numbers that multiply to 8 but add to 6? And hopefully you guys see it as 4 and 2. Now let's use our trick. Instead of plugging them in factor by grouping, let's go ahead and jump straight to the factors. If it's positive 4 and positive 2, it's x plus 4, x plus 2. All right, let's drop down the GCF of 3x, and let's drop down equals 0. And now we solve. Okay, so let's do this one first. When does 3x equal 0? If you divide by 3, you get x equals 0. That's our first solution. Next one, when does x plus 4 equal 0? Well, this one you have to minus 4 from both sides. You end up getting x equals negative 4. And lastly, when does x plus 2 equal 0? You're going to have to minus 2 from each side, and you get x equals negative 2. Remember, the trick is they just become opposite of what the factors were. So those are your 3 solutions. All right, we're doing great. Almost done. Number 3, it equals 0, so we are all set to find the GCF. Is there anything you guys can take out of both? And you're probably thinking just a single x. So let's go ahead and divide both by x. You're left with x squared minus 25. All right, and then notice the thing in parentheses. Now, it's not a trinomial, so we're not going to do a multiply-add table. This is actually the difference of 2 perfect squares. Now, do you remember how to factor that? X squared is a perfect square of x. 25 is a perfect square of 5. What is the pattern for a difference of 2 perfect squares problem? Well, it's 1 plus this, 1 minus this. So x plus 5, x minus 5. That's how you factor the difference of 2 perfect squares. Let's drop down the x, and let's drop down the equals 0, and let's get our solutions. Okay, so first one, x equals 0. No need to solve that. This one, you're going to subtract the 5, so you get x equals negative 5. This one, you're going to add the 5, so you get x equals positive 5. I kind of did some shortcuts there. So 0, negative 5, and positive 5. All right, last one, number 4. It is equal to 0, so we are good to start. Think about if there's a GCF you can take out. And it looks like they both just have a c. So let's divide out a c. You're left with c squared minus 7c plus 12 equals 0. Okay, we are back to a trinomial. So back to a trinomial means another multiply-add table. So let's do it. 2 numbers that add to the middle negative 7 multiply to the product of 12. Find those numbers. And it looks like they're going to be negative 3 and negative 4. Okay, the trick. When you actually factor it, if it's negative 3 and negative 4, then the factors are c minus 3, c minus 4. They become the factors. Bring down the GCFC. Bring down equals 0, and now let's get our solutions by setting them all equal to 0. Now this one's just going to be c equals 0. This one you're going to add 3, so you get c equals 3. And this one you're going to add the 4, so you get c equals 4. So the solutions are 0, 3, and 4. All right, thank you guys for watching. We will practice this tomorrow.